We also have an Exadata X2-2, and we ran it and we had very, very good performance of that. And I'm going to talk about why the differences in a frame or two. We'll talk about the Exadata a little bit, so if anybody's interested in that, you get a little flavor of that. But again, this gives you the statistical information of how much faster you can.
And Jason's also the first ODA customer in the world.
Yeah. Jason, being a good CTO, compare, because he wanted to shop. And I think in today's times of business climate, everybody's going to shop. And just, is this really of value? How much value am I getting here? So he went to Dell. We got a quote for two R910s. It came back to be about 35 grand. He went to Brocade because he needed a little fiber channel switching in the background. That was 22 grand. The EMC, he estimated to us to be about 100 grand. EMC did not give him a quote, but he estimated it to be about 100 grand. And overall, with the build your own 3 to 4 weeks of architecture, was 158 grand. So when we said, yeah, it's 50 grand plus some support, again, writing a check immediately. He wanted that system immediately.
Yeah, this
he
is
got
how
great performance.
Yeah.
He didn't have to go through the architecture of it, and had a system up and running in a very short period of time. So he had a lot of things that he really saw was impressive to him about the purchase of the system.
And this is also the number that I put in front of the CFO, so you can make a choice. You can write me a check right now for 50 grand, or you can write a check for 158.
Yeah. And they were, again, aging systems, needed to replace it. So just to reaffirm the subcapacity licensing of this system, you can start off with just a few cores and graduate up to 24 cores, and you're not buying any additional hardware. All of these cores are turned on and off at the BIOS level. And really the way Oracle does this is if you started off with a few cores and you wanted to upgrade to more cores, you would purchase your supporting licenses, the database licensing for that, and then you get a new CSI number. That CSI number then automatically turns those cores on for you. So again, through software, we turn on more cores as needed. And again, we walked through that process with some customers also, and it actually works pretty nicely. So again, an example maybe you take and have this non-production system and you only turn a couple of cores on, and then you want to move it to production because you need the processing powers. Now you can turn on the rest of the cores and move it into production and use it. So you have a lot of options in terms of how you use this licensing model and this subcapacity licensing model. So there's a couple of things I want to chat about here. What we're trying to state here is if you run out of headroom on an Oracle ODA engineered system, Oracle's path next is up to an Exadata system. Now Exadata comes in, I believe, 4 flavors. There's X2-2, which has 3 flavors. It's what they call a quarter rack, a half rack, and a full rack. And then they have an X2-8, which is a full rack with higher performance servers in it. I'm going to focus in on the quarter rack for a moment, because from a graduation from ODA to Exadata, that would probably be the next leap, where you would get the same number of servers in a quarter rack. You have 2 servers here, you get 2 servers there. And actually the servers are very, very similar in nature. They have 2 processors each, 6 cores, 96 gig of memory. What the big difference in any Exadata system is in the storage technology. They call it Exadata storage technology. And I'm going to just do a brief explanation of what that means or what it gives you. In a traditional database, when the server requests data from the storage, and I'm just going to give an example. Let's say you want to select the first name, last name, and the phone number from a table that has a couple million rows, okay? you might say, select first, last, phone number from table. You might have a where clause, and you might say where first name equals James, right? What happens, what's the operation in a database? The database goes to the storage cells and say, give me that table. Because the storage cell doesn't know any better. And it says, fine, I'll give you 2 million rows. And by the way, that table has 40 columns in it. You're going to get all 40 columns back too. And now it's back to the server, and the server has to filter those 3 columns out. The server has to filter out all the names that start with James. And all that work is on the server. And your database is doing this all day long. And that can create a lot of stress for that server if it has to sort through 2 million names and find all the names starting with James. And, you know, by the way, eliminate all the columns except for the 3 that were requested. In Exadata, that's not true. In Exadata, it gives him back the 3 columns that he wants. And the rows that only start with James. You have a much smaller set that's going to be returned back to the Exadata because there's the intelligence that's built into the Exadata storage cell. And that's just one of the power features of Exadata. So even though the servers are the same, the servers in Exadata are working a lot less because we've now pushed that processing power down into the storage cell. And again, that's just one example of how an Exadata is much, much faster than any other system like it because no one else has this technology. IBM doesn't have it, HP doesn't have it, EMC doesn't have it. No one else is doing this. Not in a general purpose Oracle database environment. So some of the other things that are going on, you have smart cache technology, you have HCC, which is a compression technology for data warehousing. You can upgrade an X2-2 to an X2-2 quarter rack to a half rack. That's in place upgrade while the system's up and running. Very, very sophisticated engineered system. Again, when you start here, you can graduate to this. All of your licenses would migrate right to the Exadata system itself. So again, if you like the concept of an engineered system but afraid of expanding it up, where do you go? In Oracle's world, you go right up to an Exadata system.
And for the for you guys who's running Enterprise Edition 11.203, hover column compression right now is available as a feature.
That's correct. The HCC capabilities at 11.203, the latest version of 11.g02, is available on any Oracle database using Oracle storage technology. So it'll be available for ODA, Exadata, if you're running a ZFS appliance, if you're running Pillar storage, all of those would be acceptable storages for using HCC technology.
And HCC allow you to do what, 10-to-1 compression?
Yeah, it's very, very high compression, again, oriented for a data warehouse environment. Now, I'm going to digress in 2 other pieces a little bit. Today, the ODA system is running 11GR2. It's 11.202, not 11.203. Now, 11.203 is available, but with ODA and also with Exadata, you have a separate management group that certifies releases of all the software and patches, including the database. They are in the process of certifying 11.203 for ODA, which they expect to be released in April, in about a month. So you have a separate layer, an actual group of people in the engineering group at Oracle that certifies and tests all software to be released on the system. Again, an extra layer of service related around this offering. Again, for you, if you're running a non-engineered system from Oracle, you would have to go through that certification yourself. Oracle says, yeah, it's good to go on your HP system. Well, you know darn well, with the history of Oracle and any software for that matter, that you have to load it, test it, make sure it doesn't cause any other problems with the hardware, Oracle's done that work for you. And that's why the releases will be a little bit later than when the database people release things. The last note on this screen is that, and I mentioned this before, but I want to make sure everybody understands, is that you can expand the disk subsystem of this 4 terabytes to something larger through what Oracle has certified, or this engineering group has certified in an NFS system like a ZFS appliance. You can attach a ZFS appliance and expand the disk subsystem storage that's available to both servers. So again, we do have lots of expandability with the system, either growing up and graduating to Exadata, or growing the storage by going to an appliance like ZFS. Okay, change gears a bit. We've talked about lots of things. Now I'm going to talk about deployment options as it relates to licensing. Again, I would say 95% of the deployments we've seen so far deploy in an Oracle clustered system. What does that mean? You have 2 active servers on a common set of data files servicing your database users, whether it be applications, ad hoc users, whatever it is. You have 2 servers that are actively servicing that community. The servers automatically load balance that load across both servers. That is Oracle's RAC, or Real Application Cluster Environment, and that implementation has certain licensing implications. Many times, an application cannot run under that active, each server servicing the community. Applications aren't built for it, and we've seen that before. But you want some HA capabilities. You can implement where you have one active server servicing your users and one standing by idle. If there's a problem with this server, then it automatically fails over to this server seamlessly. So your users don't know, and there's no work on your part. That's called an active passive cluster. Oracle's term for it is RAC 1. That has different license implications for you too. But it's basically the same clustering software for each that manages both of those. Now you might say, gee, that's really a waste of time. Why would I have a server sitting there idle and have this one active? Well, what you may do is put another database over on this server and a database over here and have them fail over to each other. And that can be done also. So you could have 2 independent servers operating against the same disk subsystem, but different data files, and each server fail over for each other, which is totally capable with this system. So you have lots of options in terms of implementing this and getting an HA capability with the system. And all of these circumstances have different licensing implications. And again, once if you're interested in talking more, James or myself can help you out with that. Now we go into comparing the system. Right now, my laptop is in the back there, and I'm remote desktop into a workstation at our office. I'm actually going to do a live demo, and a lot of people think, oh, you're nuts. You're going to do a live demo, but yeah, we're going to do a live demo. I'm that kind of crazy. So we're going to compare it, and what we're going to compare is, I call it the champion. In our data center, our lab, I have a 2-node Dell system, 1950s. This system has been very, very rock solid for us. It's been up for 4 or 5 years. We've never had downtime. We've never had any problems with it. It's been an operational database for that long. It has definitely a legacy system that we need to replace. Has a couple of processors, a couple of cores in each processor, 16 gig of memory, Oracle Enterprise Linux, 64-bit, 11 GR2, real application clustering. We have an EMC 500 with a couple of trays of drives, 2 gig interface to the disk storage system. We know the OTA, we went through that. It's got a couple of processors. They're bigger and faster processors with more cores. We have a lot more memory. Same software configuration just about, except for we're running 11GR2. And we know what the Sun storage is. 2600 gig drives, 15,000 RPM. The interface between the servers and the storage is a HBA 6 gig interface. And we've got the SSD drives. The software I use to run this test is actually a test against the servers. It's a load test, basically. It's called Swing Bench. Swing Bench was built by a gentleman in England, an Oracle employee. He does this in his spare time. Stephen, I'm not sure how Oracle employees have spare times, knowing your schedule. That's another story. He's built a number of workbenches into the software, and it's built specifically for testing a clustered system. The workbench that we picked out was called the sales order workbench, which has a blend of processes that it runs. It's a Java client executing PL/SQL against the database. Everybody, PL/SQL being the core programming language in the database. We basically vary the number of sessions. In our test, we're just going to run 2 tests because I don't want to waste a lot of time. We're just going to run the tests that really kind of max the servers out. I've done this already. The things that I'm going to look at or I'm interested in, actually it's the one thing I'm interested in because, at the end of the day, the database is there to service users, and what's most important to users? Response time. They want to get on with their day. They don't want to be waiting for data from the database. So response time is the most important thing we're going to look at. Swing Bench actually calculates that for us as we go along. So it's going to tell us what our response time is. We've got some traditional things that we're looking at, transaction per second, transaction per minute. That's again from Swing Bench, calculates that for us. Then there's a couple of things within Linux Top. Does everybody know Linux Top? Unix Top? Okay, good. Load average, again, from a management standpoint, we look at load average as stating what's the overall stress of the system. How stressed is my server at this point? So that's pretty important. We want to know, when it's really stressed, that's when problems occur. And more traditional things, the CPU usage and memory usage. Look at those. Now, I'm going to go back there and I'm going to switch screens to my remote desktop into our lab, and I'm going to be chatting from there. Okay, so this is a depiction of the Swing Bench software here, and we are now logged into DB1, or Helm, is our Dell EMC system. Okay, here's our load mix that we talked about that's going to be executed. Right now I have the user count at 500. That's 500 concurrent sessions. I'm actually going to increase that to 750. And because I'm blind, I have to put glasses on. Okay, so I've got it set at 750. And I'm going to go ahead and, oh, by the way, there's a couple other data points we can look at. Can we see that okay? DB1, this is DB1 here, and DB2 down here. The 2 servers. And the note I want to note is right now this is about 230 tasks. That's about 230, close to 230. They're both running about 200 plus processes right now. Okay? The load average, the 1 minute load average is pretty low, sub one, and that's getting cut off a little bit, but it's sub 1 too, that I can see also. Okay? And then we could see the CPU, this user count is where the CPU usage for users are. again, we're pretty low. This thing is idling along right now. Not a lot of load, not a lot of things going on, okay? Back to swing bench for a moment. I'm going to go ahead and start this. And first thing I want you to note is how long this takes to ramp up. Again, slower server, doesn't respond really fast. Takes a while for this thing to really ramp up and get going. This disk I/O and this CPU are against one server. It's against DB1, so we can ignore that, or we can get an idea what at least one server is looking at from their graph. But again, pretty slow to ramp up. You'll see that once we go to the ODA system, that it'll ramp up much faster. But it finally gets up there and is going. And as that's ramping up, I'm going to switch back to the top sessions. Now that we're at 750, we can see that this has gone up to about 530 or almost 300 connections, and this has gone up a little more in the 600 connection range. So this happened to me yesterday on this system. Again, older system, didn't load balance out quite right, but pretty close to load balance that load across both servers. You can see though, the load average on this thing is just through the roof. Anybody using this system right now is not getting good response time. You can see the CPU usage is way up there also. Okay, so these servers are getting hammered right now, and top is telling us that. The CPU usage is telling us that. We're not caching too much. If you look at memory, that's real memory. We're only using 16 gig of the memory. We got a little bit of cache going on, but not really caching that much. So again, not really a server thing. It's just older technology that you're seeing. Going back to here, we can see the graphs going here. Here's our response time. Our average response time is 357 milliseconds. Again, that's pretty slow. I mean, this thing's getting hammered pretty well, and our max is 2200. Again, pretty slow. And again, this is only a 3-minute test. We're not going to, make this too lengthy here. But again, you can get an idea. This server's, although doing pretty good, 750 concurrent sessions or users, pretty darn good. We've had, again, pretty good success rate for this thing, but it's pretty much saturated right now. And that was sort of the point. I didn't want to go through and show you all the different stages, but just show you when this thing actually saturates out. And we started at 56, and we're at 58, so we got another minute. We can go back to our top sessions. Oh, it did log off. It went back down to 0, so that means it's all done. And you can see now the loads and everything is calming back down. But I guarantee you, my DBAs back in Westlake Village are screaming right now. They've just had a whole bunch. We have some monitoring software on there, so they just got alerted saying, you've hit these thresholds, it's running slow, what are you doing? And I expect text messages any moment and say, stop your demo. Okay? All right. Let's go over to our ODA system. By the way, we named our ODA system Mini-Me. What's that from, James?
Austin Powers.
Austin Powers. So we have the Exadata, and then we have Mini-Me. And they're right next to each other in our lab. And so, my DBAs, like anybody else, do have a sense of humor and named it Mini-Me. Anyway, we can see the ODA just sitting there idle has about 500 processes. It has a few more. That has to do with 11GR2 has a few more things running. And we've got the Enterprise Manager agents running, and we have the Application Manager that runs. So we have a few more processes running. But you can see load average is pretty low, And again, we can't see Mini-Me 1, but it's pretty low also. And we're using almost no CPU. Again, just a foundation to say this is where we're started and this is where we're at. Okay? I'll go back to swing bench for a moment. And open up the config to run the Mini-Me. I'm at 750 users. I'm actually going to change that to 1250 because again we want to stress it. Okay? And we're going to go ahead and start that. First of all, I see how fast it's going to log in and whatnot. It just logs in faster. I mean, it just goes. And it's done. So, again, faster response time. Now, we would expect that. This is newer technology, a better system. But again, we're just supporting that fact that this thing is, runs very, very well. And we'll go ahead and turn on and look at top. Now we can say, this has about almost 1150 processes, 1150 load balanced out pretty nicely. So it load balanced it very, very nicely, much better than my Dell system. And again, what you would expect. Our load average is, this thing is still just cruising along. No big deal. Very, very little CPU usage. Again, cruising along pretty well. Go back to our statistics, our workbench. And again, now we can see our response time a little dicey. And this is a piece where, again, we pretty much hit the max at 1,250 users because our response time is a little dicey. And our transactions per minute and per second are pretty nice. But again, our average response time is pretty dicey, although the server is cruising along. And I believe that, I haven't dug into this, but my guess is it probably is I/O, in an Oracle database. What slows it down most often is, performance and I/O. But again, how many people in the room are running 1,250 concurrent sessions in their database today? I have had some people say that, so, it's not uncommon. But generally,
around 20 cities.
Yeah, this is our 20th presentation. I can say the number of people who said they're running 1,250 sessions is maybe one or two. So again, are you running this blend of processing? Probably not. Probably something different. But you can get an idea that this thing's being pretty responsive at 1,250 concurrent users, and not being stressed that much at all. So again, live demo, it should be wrapping up here shortly. 103, 101 should be wrapping up shortly. We'll go back to our top sessions. Again, these servers aren't working that hard right now. From a processing standpoint, 1.5% of users CPUs. The load average 142. If you remember, the Dell system was in the hundreds. People are getting still serviced by this thing. So back to this. I just want to make sure it finishes. It should. Yeah, it's all done. Anyway, that is kind of a comparison of our legacy system to. We don't need to see that. Our legacy system and the ODA system. There's probably a 5 or 6 year difference in technology stack, and I guess to say, yeah, it definitely looks like a 5 or 6 year difference in technology. Okay, I'm going to flip back to our PowerPoint. I have some summaries here of statistics. I did these back in December. We actually had a lull in these little presentations, so I had some time to put together and run these sessions all together. Oracle, and 1250, that's probably about the numbers we saw. We saw a lower load average, much lower. The lower load average relates to the fact that there was a BIOS patch that they installed about a few weeks ago. And this BIOS patch was specifically to tune up the processors. And so you can see how that affected that processing